This question provides an example of working with the normal distribution. A manufacturer has a machine that fills bags with flour such that the weight of flour in a bag is normally distributed. A label states that each bag should contain 1 kilogram of flour. The machine is set so that the weight of flour in a bag has mean 1.04 kilograms and standard deviation 0.17 kilograms. Find the proportion of bags that weigh less than the stated weight of 1 kilogram. So here we're working with the distribution that is normal with mean 1.04 and standard deviation 0.17. And we're interested in the proportion of bags that weigh less than 1 kilogram. So there's the mean 1.04 and there's 1 kilogram, and we're interested in what proportion are in there. On our calculator we use the normal cumulative distribution mode, and we have to put a lower bound in for that area and an upper bound in for that area. Well, you need to be at least 6 standard deviations away from the mean to be sure you've got all the area down to the bottom end of the tail. But there's nothing to stop you putting a ridiculously big negative number in there like minus 1000. And the upper bound would be 1. Sigma, the standard deviation, is 0.17 and mu is 1.04. And if we now press the equals button on the calculator, we'll get the probability that x is less than 1, and that turns out to be 0.407. And we're asked for the proportion. Maybe we could give that as a percentage, 40.7%. But I think you get the mark if you just left it as the decimal 0.407. Moving on to part B. The manufacturer wants to reduce the number of bags which contain less than the stated weight of 1 kilogram. At first she decides to adjust the mean but not the standard deviation, so that only 5% of the bags filled are now below the stated weight of 1 kilogram. Find the adjusted mean. Well, we're now working with the distribution that is normal. We don't know the mean. The standard deviation is still 0.17. And we're going to need the inverse normal mode on the calculator. But we can't use it directly with this distribution because we don't know both sigma and mu, and to use the normal functions on the calculator you need both a standard deviation and a mean. So what we do here is we use the standardized variable z, and z has a mean of 0 and a standard deviation of 1, and we want 5% to be below this weight of 1 kilogram. So we try and find the z value that has 5% below it. So what we do is we put 0.05, 5% area from the bottom left hand end. Sigma is going to be 1, mu is going to be 0, and when we hit the equals button, that will give us the z value where 5% are below that value and 95% above. And when we put that into the calculator we get minus 1.645. Minus 1.645. Now z is related to the variable x by z equals x minus mu over sigma, and we're trying to find mu. So let's multiply up by the sigma and get z sigma is equal to x minus mu. And if we take mu to the other side, we get mu equals x, take the z sigma to the other side, we get minus z sigma. So mu is equal to the corresponding x value, which is 1, that's what we want there, minus 1.645 multiplied by sigma, which is 0.17. So we've got a double negative there. Mu is 1 plus 1.645 multiplied by 0.17. And we put that in the calculator, and to 3 significant figures that's 1.28. So mu would be 1 0.28 kilograms. Part C. The manufacturer finds that a lot of the bags are overflowing with flour when the mean is adjusted, so decides to adjust the standard deviation instead to make the machine more accurate. The machine is set back to a mean of 1.04 kilograms. The manufacturer wants 1% of bags to be under 1 kilogram. Find the adjusted standard deviation. Give your answer to 3 significant figures. So this time we're dealing with a distribution which is normal, has a mean of 1.04, but we don't actually know the standard deviation. So we want a mean of 1.04. We're interested in the amount of bags that are below 1 kilogram, and that's the x variable. But again, we'll have to use the standard variable z because we need to know a value for both mu and sigma to use the calculator. So we've got a mean there of 0 for z. What will be the z value if 1% is below that line? So we put in here the area is 0.01, 1%. Sigma is 1, mu is 0. And when we put that in the calculator, the value we get is minus 2.3263. And again, we can say z equals x minus mu over sigma. That's what relates z and x. And we try to find sigma this time. Sigma z is equal to x minus mu. So sigma is equal to x minus mu divided by z. X, the critical x value is 1, mu is 1.04, and z is minus 2.3263. And here we've got a negative on the top and negative on the bottom, so that will give us a positive overall. And if we put that in the calculator to 3 significant figures, sigma is 0.0179 kilograms. And that is the new standard deviation. And that completes the question.